Hi, my name's Jo Morgan. I'm the writer of the website resourceaholic.com and the book A Compendium of Mathematical Methods. Today I'm going to do a short video explaining a method for finding highest common factors and lowest common multiples. This method can be called the factor method or the ladder method and has various other names. I'll just start with a quick note for overseas listeners. In England, this is called highest common factor, but around the world, it's more commonly known as greatest common divisor. They mean the exact same thing. I'll also be talking about lowest common multiple, which is also often referred to as least common multiple. In this video, I'm not going to talk about the concepts. I'm not going to explain what these things are because this is a video for teachers, not for students. So I'm obviously assuming a lot of prior knowledge here. And all I'm doing is talking about methods for finding these things rather than what they actually are. This is not a conceptual explainer. This is about a particular method, and I'm going to give some examples of how that method works. Now, all around the world, there are multiple methods for finding highest common factor and lowest common multiple. Normally, a teacher will choose one method to teach their class. Sometimes a teacher will show multiple methods and let students pick. If you read my book, A Compendium of Mathematical Methods, I have listed a number of them, including the old-fashioned listing method, methods involving prime factors, Venn methods, the ladder method or factor method I'll talk to you about today, a table method. We've got some lovely old methods from textbooks from hundreds of years ago that are fascinating. Euclidean algorithm, nice way of finding a highest common factor. And then modern calculators just do it all for us. So there's a whole range of methods out there, including some I haven't specifically mentioned in the book because they are just kind of variants of things that I've talked about. For example, if you look this up online, you'll see these things like the upside down birthday cake method, but they're all kind of related and generally they're all doing the same thing. They're just different formats, different layouts. So there's a whole load of methods we can talk about. But when I was training to be a teacher, I had to teach highest common factor and lowest common multiple. And my mentor at the time sat me down and said, let me tell you what the method is. And she showed me the Venn method and I accepted that as the method. At the time, I didn't question it. I didn't say, are there other ways we could do it? I just said, oh, right, that's how you do it. And then for the next 10 years, that's how I taught it. And I only discovered there were other ways of doing it when a student actually showed us that she'd learned a different way in a different country. And that's when I thought, oh, hold on, there's not just one way of doing this. There's a whole load of stuff that I don't know about. And actually, that's one of the things that prompted me to write my book about methods and to do a lot of research into methods around the world. Now, I'm absolutely not saying there's anything wrong with the Venn method. I think the Venn method is one of the most commonly used methods in the UK, and there's nothing wrong with it at all. If we were to talk about pros and cons of it, there's a few things that can cause difficulty. For example, it can be a bit inefficient. I mean, you have to do prime factorization first, and prime factorization might take a while. Also, sometimes students get confused about which bit's the LCM, which bit's the HCF, particularly forgetting how to find the LCM once they've put the numbers in the correct sections on the Venn diagram. But there's also lots of advantages of it too, and it is, like I say, a very popular and a great method. So I am not criticising that method at all, and I have used it myself many times before. My preferred method now is the one that I'm going to call the ladder method, or the factor method, or various other names for it as well. That's what I'm going to talk to you about today. I'm going to show you how it works, but also answer a lot of questions about it, because people often, when I talk about this, they say, oh, but it doesn't work for three numbers, which is wrong. Of course it does. And also I want to show you how great it is for some sort of problem solving questions as well. So we'll start with a nice simple example here. We'll look at the highest common factor and lowest common multiple of 140 and 42. Now I tell students to start by setting up a little grid. 140 and 42 just written next to each other, and they can draw a line underneath it, and they might want to draw a line down the side as well. Now I need to find a common factor of 140 and 42. The way this differs to some other methods is it doesn't have to be a prime factor. And quite often when you look at methods for this topic online, you see that it's all about taking out primes. Now I can take out a prime here, but I don't have to. In fact, I am going to take out a prime. I'm going to take out a 2 because they're both even numbers. So that might be something that's quite accessible to students, is checking first whether they're even. Now if I divide this one by 2, I get 70. And if I divide this one by 2, I get 21. Again, I'm looking for common factors. I can see 7 goes into both of these. I happen to have taken out a prime. It doesn't have to be prime. So I'll divide this by 7 and I get 10. And I'll divide this by 7 and I get 3. Now these two numbers, 10 and 3, are co-prime. They have no factors in common, which means I stop and I'm ready to now write down my HCF and LCM. So to get the HCF, the highest common factor, I just multiply the two factors that I wrote down the left-hand side. So 2 times 7 is 14. So that is my HCF. My lowest common multiple, I want to take these factors that I've written down the side, but also the factors along the bottom. And one thing that some teachers find quite helpful here is describing it as the numbers in the L shape, L for LCM. So we have this L shape down the bottom, 2 times 7 times 10 times 3. What's that give me? 14 times 10 times 3, so that's 420 is the LCM. And yeah, that L shape thing, and LCM and L shape is just quite a nice little memory aid for students. So they look for the L and then they know that's the LCM. So that was pretty quick. I happened to find prime factors. I didn't have to find prime factors. I didn't do the prime factors as a 10, wasn't necessary. And you can see that it's a very easy structure and in fact quite memorable for students. I'll show you another example. So in this case, I'm going to write 250 and 200 next to each other. Again, I can do a little grid. And then I'm going to say, right, what goes into both of those now? Maybe I take out 10, maybe I take out 50, spot the highest common factor in one go. Let's see, I could take out 2. I'm going to go for a 10 here because I just want to show an example where I'm not taking out a prime. That leaves me with a 25 and a 20. 5 goes into both of those, so let's take out a 5. So we've got a 5 and a 4. And these two numbers are co-prime, they have no factors in common, so I can stop. Okay, so here's my HCF. So HCF is 10 times 5, which is 50. And again, let's look for that L shape. There's the L shape there. So the lowest common multiple is 10 times 5 times 5 times 4. So what's that? 50 times 20, so 1,000. Again, you can see it's pretty quick. Now, I'm not saying that quick is necessarily the most important thing when we're choosing methods. Yes, the Venn method would take longer here because you'd have to do 2 prime factorizations, which would take a while. Then you'd have to fit them all into the Venn diagram, and then you'd have to work out your HCF and LCM. Now, efficiency shouldn't be the main thing we're looking for in a good method, but it's worth mentioning, isn't it, that this is a highly efficient method for finding highest common factors and lowest common multiples. Right, let's look at another example, 315 and 420. I'm writing them next to each other in my grid. Now, these are numbers where I definitely wouldn't want to use a listing method. I'm a big fan of listing. If I ask students to find the HCF of 12 and 36, of course I want them to list or just notice it, just by inspection they should know the HCF of that. Or say I wanted them to find the LCM of 48 and 64. Again, I might want them to do it just by listing some multiples, or just again by just inspection. But for numbers like this, 315, 420, no, I don't want them to do it by listing. I think it's just going to be too time consuming for them, and I think they do need a formal method for doing it. Here, they're not both even numbers, so I'm not taking out a 2, but I can see that 5 goes into these. I always encourage students to do a little working at the side if they're not sure. So if they don't know how many 5s go into 315, they can just work that out down here. So we've got 63. So write 63 here. Again, if we don't know how many 5s go into 420, they can just quickly work that out here. So what have I got there? Remainder 2, and then I've got 84. Okay, now at this point they might be looking at these saying, do we know what times table these are in? Let's see, can we take out, so this is 7 9s and this is 7 12s, so let's take out a 7. Need to know times tables really well. It's absolutely vital that students are fluent in times tables from a young age, because otherwise so much secondary school maths is totally inaccessible to them. It's not about them sort of counting up on their fingers through their times tables, it's about them recognizing these numbers. Okay, so 7 9s and 7 12s. Okay, we're not quite done because 9 and 12 share a factor of 3, so let's take out 3, leaving me with a 3 and a 4. Okay, now they're co-prime, so I can stop there. Right, so our HCF is these numbers multiplied together, 5, 7 and 3. So 5 times 7 and 3, always the numbers that are down the left-hand side. So that gives me 105. So that's right. And then lowest common multiple, I'm going to find that L shape again. There it is. So lowest common multiple. Oh, it's a lot, isn't it? 5 times 7 times 3 times 3 times 4. 1,260. So not one that I would want them to have to list out multiples to find. I think it would be better for them to use a method like this. Right, and here's an example where something a bit different might happen. I mean, this could happen in any example, but this is a particularly likely case. In this situation, I think students looking at this are likely to spot that both these numbers are in the 9 times table. So, you know, we can take out a 9 from the 54. 54 divided by 9 is 6. And then 45 divided by 9 is 5. These two numbers are co-prime. So we've basically got it in one. Our HCF, highest common factor, is 9. So just this number here, because we just immediately spotted that 9 was the highest number that went into both of these. And that means that our LCM, we don't actually have that L shape. So it's a little bit problematic to use the L shape because then you get examples like this where it's just a straight line. But I think as long as it's addressed in examples, then it's fairly easy to remember and for students to understand that, you know, it's sometimes it's all just in one row, and that will be because you happen to have taken out the HCF in one go. So this is going to be 9 times 6 times 5. So what's that? 9 times 30, so 270. So that is something that if you set a task and you start off with quite low numbers or quite simple examples in the task, students will probably come across this immediately. So you have to make sure you have modelled it. Otherwise, you're just going to be inundated with questions very quickly on what do I do in this situation where there's no L. And it does make me think maybe we shouldn't make that reference to L shapes if that's going to confuse them. But no, I think it's fine. I think it's just make sure that the example's there. And, you know, this is obviously an incredibly quick way. Again, compare this to a method where you have to start with a prime factorisation, and you'll see how very efficient this is to find an HCF and LCM. Now, one thing I like about this method is that you can use it for all different types of scenarios, and now I'm going to show you some slightly different exam style questions that might come up. So sometimes in exams they actually give you the prime factorisation, and that does mean that a Venn method would be incredibly quick, but then this ladder or factor method is also incredibly quick. It doesn't matter if they've done the prime factorisation for you. In fact, that's going to be helpful to us because we don't have to think about the factors, we have been given them. So instead of writing the 1684 at the top, I could actually write those prime factorizations like that, and then I could just do this in one go. You don't have to do it in one go, but I can see the common factors straight away. There's a 2 squared and there's a 3 in both of them. So, you know, I could have done it in 2 steps. First of all, take out the factors of 2 and then take out the factors of 3, but no, I think I'm just going to do it in one go. There's the HCF, and that left me with a 5 here and a 7 here. So very quickly, I've got that the HCF, the highest common factor, is 2 squared times 3, which is 12, and the lowest common multiple is 2 squared times 3 times 5 times 7. This is very similar to the example I just showed you, where instead of the L shape, everything's just written in a row. And what's that give me? 420, I believe. Okay, so you can see that if they do give you the numbers and they've been decomposed into prime factors, it doesn't really make a difference. It just means it's a little bit easier to identify which factors to write on the left-hand side. I have seen students make mistakes with questions like this before, where they have basically, even though they've been given the prime factorisation, they've just then written out the numbers at the top and sort of factorised from scratch, which is so unnecessary. I've even seen examples where the numbers themselves weren't given, just the prime factorisations, and students have started by working out the original numbers. And I just want to be really clear with them that if you've got the prime factors, then use the prime factors. I gave this question to my class the other day. They were all working at about a grade 4 at GCSE. They were very pleased with themselves that they managed to find the highest common factor and lowest common multiple of such big numbers, seemingly with ease. So again, I could do this in steps. In fact, I'll do this one in steps. I could take the prime factors out all in one. I'll just do it in steps for demonstration purposes. So first I'm going to take out the 2 squared. So I'm left with a 3 to the power of 5, a 5 squared and an 11. and then I'm left with a 2 squared, a 3 squared, a 5 and a 7 cubed. It was interesting when I did this with my class recently. It led to a really good discussion about how we already know how to factorize algebraically. You know, they know that if they had an x to the power 4 and an x squared, and they were in an expression and they were factorizing, they know that they'd bring the x squared out to the front. So it's a really similar skill. Let's take out a 3 squared, because some of them were saying that 3 to the power 5 would come out to the side. And so I had to sort of go back and just sort of talk to them about you know, how they know how to do this with algebra, and it's exactly the same idea. And how can they take a 3 to the power 5 out when there's only 2 3s over here? Like, it was a good discussion, and I'm glad I did these examples. So I've taken out that 3 squared. Let's take out a 5. Probably going to run out of space here. 3 cubed times 5 times 11. 2 squared times 7 cubed, and I think I'm done, aren't I? Yeah, so these are now got no factors in common. 3 cubed times 5 times 11 and 2 squared times 7 cubed. So I'm not going to work, it says leave your answer to product of primes, so I won't bother working them out, but the highest common factor here is 2 squared times 3 squared times 5. So I will leave that in prime factor form. And then when I did this with my class, I said, oh, look, here's our L shape LCM. You know, we've already seen it doesn't have to be an L, but it's essentially just the highest common factor multiplied by whatever's kind of left over. And I did talk to them about how we can gather up these like terms. So I've got 2 squared times 2 squared is 2 to the power 4. 3 squared times 3 cubed is 3 to the power 5. I've got a 5 times a 5 there, so that's 5 squared. I've got a 7 cubed and I've got an 11, and then they might notice some stuff. And this is a great one for noticing how the LCM is essentially like the highest power. So it's the highest power of the 2s, it's the highest power of the 3s, it's the highest power of the 5s, the highest power of the 7s, and the highest power of the 11s, and that's what makes up our LCM. And there are other methods that skip straight to that. Without all this. So, you know, arguably we could, once we know what we're doing, we could write all that down without any of this method. And some people call this winners and losers is one of the names people use for this technique of sort of identifying that the losers are all the lowest ones and the winners are all the highest ones. And yeah, you know, like I say, this, of course it's all the same thing, because we're finding highest common factors and local multiples. All of our methods are essentially equivalent, they're just different formats. But I know what I'm trying to show here is that the ladder method or the factor method can be used when you are given the prime factorization, but the beauty of it is that you don't need the prime factorization. I don't think we necessarily need a formal method to do this algebraically, but I just want to show you that this works absolutely fine if we want to do a method to find the lowest common factor and highest common multiple of algebraic terms. The reason I don't think we need a method is I think if you shoved a plus sign in between these two terms and asked students to factorize it, then they'd be able to pull out the highest common factor, and they wouldn't even necessarily have to think about it too much, because the factors are right there looking at us in the face. It's not like numbers where you have to find the factors. The factors are clearly visible in an algebraic situation. So students can factorize these just by inspection. The lowest common multiple, again, might be slightly trickier, but basically if you imagine these were denominators of fractions and you ask students to find the lowest common denominator, it's the same skill. So yeah, the nice thing with algebra is that all the factors are just there for us, apart from for the coefficients, those numbers there. So let's say, well, I know that 3 goes into both of those. So I'm going to do this one. Should I do it in steps? No, I'll do it all in one go this time. So a 3 comes out, an x comes out, a y squared comes out, and a z squared comes out. So that's the highest common factor in one go. And then what's left, I've got a 3, a y, and then here I've got a 2, an x, and a z, unless I have made a mistake there. That looks good. Okay, so you can see that my highest common factor we did manage to pull out in one go, because we can see the factors so easily with algebra. And the lowest common multiple is going to be all of this times together. So what have we got? A 3 and a 2, so we've got an 18, an x and an x. Oh, this is that same thing as before, isn't it, where it's the highest terms or the highest powers in the original expression, or the original terms, and this is z cubed. Okay, so there's the LCM. So yeah, it works fine with algebra as well. This year I played with some problem solving with this method and it turned out it worked incredibly well. I never really thought of this before. I want the highest common factor of two numbers I've been given and the lowest common multiple of two numbers I've been given. I need to work out what the two numbers are. Now this becomes really simple if you use this method. Like, it's really just a case of filling in blanks. Let me show you what I mean. So I know the highest common factor of 140 and x is 20. So I know that the number I take out here, and I don't take anything else out, that's the highest common factor. Now, 140 divided by 20 is 7, so I'd have a 7 there. And then x divided by 20 would give me the number here. Now, I don't know that number at the moment, but I do know that the lowest common multiple is 420. So we know that if we times these, multiply these three numbers together, I get 420. So then I'll be able to work out that number, and then I'll be able to work out x. So what have I got? 140 times 3 is 420. So that must be a 3. And then, so now I know that x divided by 3 is 20, so x must be 60. So the highest common factor of 140 and 60 is 20, and the lowest common multiple of 140 and 60 is 420. Now, I think in the past, I thought that this was quite a hard one to explain to students how to do this kind of question. So I'm really pleased that it works so well with if you've taught the ladder or the factor method. It is just a case of filling in blanks in a table, and it makes that question really accessible. I'll just show you one more like that because I just think it's really lovely, isn't it? So we've got the highest common factor and lowest common multiple of x and 12. So they go at the top. The highest common factor is 4, so let's put a 4 here. Now 12 divided by 4 is 3, so that would have to be a 3 there. But we know the lowest common multiple is 120, so when we multiply these three numbers together, so whatever goes here, upon the 4 and a 3, we get 120. So 4 times 3 times something is 120, so that something must be 10, so let's put a 10 in there. This must therefore be 40. Yeah, x is 40 because 40 divided by 10 is 4. And let's just check it makes sense. So we've got the highest common factor of 40 and 12 is 4. Yep. And the lowest common multiple of 40 and 12 is 120. Like, that totally makes sense. So this is 40. As you can see, it's a really nice little way of solving problems like this. People often say that the ladder or factor method doesn't work for three numbers, and I just want to show that that's not true. It absolutely works for three numbers. I'm not a big fan of doing it with three numbers because I kind of don't see the point of it really. Like, I think at GCSE the specification says that they could ask students to do this for three numbers. Well, it says at least two numbers. But I think it very rarely comes up in GCSE exams, and if it was an example like this, I would just have students list the factors and list the multiples and figure it out from there. I don't think we really need a formal method for this. You know, there's no method that's great, like the Venn method is very cumbersome for this as well. But yeah, I just want to show you that it does work. You know, we can do it for three numbers. What we do is we say, I'm going to take out the highest common factor. In this case, we'll probably get straight there, won't we? It's going to be 10. And what does that leave us with? A 2, a 3 and a 4. So this is the highest common factor, so I already know that. There's nothing else that comes out of all three numbers because we need students to have a conceptual understanding here of what the highest common factor is, and we need to know that it has to be something that's a factor of all three numbers. So that means we stop at that point. But we haven't actually got to the LCM yet. If I look at across here, all three numbers don't have a common factor, but 2 and 4 do have a common factor. I'm going to take a 2 out. Now I just have to be aware that's not part of the highest common factor of the three numbers because 2 doesn't go into this 3. So I've already got my HCF, I've banked that, and then I'm just going to carry on taking out factors. So that divides by 2, that I'm going to leave as it is, and that divides by 2. You know, you don't have to necessarily write this one in, you could just leave it up there, but you know, I'm just going to carry that down. Okay, now I've got my lowest common multiple. So lowest common multiple, again, I'm just looking at that L shape. So remember, the highest common factor is not both those numbers down the left, it's just the one that went into all three. But the lowest common multiple, I did need to keep going and take out any other common factors. So it's 10 times 2 times 1 times 3 times 2. What have we got? 20 times 6 is that? So it's 120. Okay, so you know, it does work absolutely fine. I don't think it's worth spending a long time teaching this particular skill. But yeah, for people that say this doesn't work for three numbers, I disagree with that. I'll show you one more example with three numbers. These are slightly more difficult numbers this time. Again, just to demonstrate this does work if you have three numbers. Right, I'm going to divide them all by 2. I know there are bigger factors, but let's just sort of looking at it from a student's perspective, I might just say, well, they're all even. So let's start by dividing by 2. What's that give me? 54. Okay, I'm going to divide by 2 again because I've got a load of even numbers. What have I got here? 12, 18, and 27. Okay, I'm going to divide by 3 now. So what do I get? 4 and 6 and 9. Okay. There's no common factor of 4, 6, and 9. So this means I have now found my highest common factor of the 3 numbers. So highest common factor is 2 times 2 times 3, which is 12. Okay. However, I can keep going because I could take out a 3 from the 6 and the 9, or I could take out a 2 from the 4 and the 6. So let's take out a 2. It's not part of my highest common factor. So that's a 2, that's a 3, and then we'll keep this one as it is because we can't take a 2 out of that, so just keep it as it is, but these 2 we divided by 2. I can now take a 3 out of the 3 and the 9, so again I'll keep this one as it is, but this one becomes a 1 and this one becomes a 3. Now I can't take anything out of 2, 1 and 3, so let's highlight that L shape for the LCM, and again we're just remembering LCM. Sorry, you can tell I'm not used to making these videos because that's really messy. This is 2 times 2 times 3 times 2 times 3 times 2 times 1 times 3. So we have to be careful. The HCF is not the whole left-hand side. It's just the ones that came out of all 3 numbers. But for the LCM, I want to go all the way down and across. Let's see, what's that? 4 times 3, so 12, 24, times 2. Let's see. I believe this comes out at 432. 432. Okay, so yes, you can do it with 3 numbers. It absolutely works. So I hope you enjoyed learning a bit more about the factor or ladder method, various ways we can use it and things that might come up when we teach it. Have a go with your students, see how they respond to it. You might want to show them that and another method. For example, if you normally teach the Venn method, you might want to teach the 2 different methods side by side and let your students decide which one they prefer. Talk to your colleagues about it, discuss it in department meetings. And if you enjoyed learning about this method, then you might enjoy my book, A Compendium of Mathematical Methods, where I have chapters for various different topics in primary and secondary maths. Where you can learn about different methods from around the world and from the history of maths back in Victorian times, all different ways that people have done things in maths, all different ways of working things out. So if you're interested, then do buy my book. Thank you very much for listening.